vector is its unity vector. That unity vector can be given a particular magnitude. Once we find that particular vector, we can just multiply it by magnitude. If at all we are looking for a parallel vector of given magnitude. So the same applies to this. So now, if Q is equal to AI, for example, plus BJ, okay, then the unity vector, of Q is Q with an inverted V, which is given as vector Q over the magnitude of Q, which is now going to be simplified as AI plus BJ over the square root of A squared plus B squared. This is the unity vector, and it is the parallel vector, and it is the vector parallel to vector Q. So a unity vector will always be parallel to vector Q. So if they happen to say that a vector parallel to Q has a magnitude of K, then we are going to find the unity vector, multiply it through by K, then we would have obtained that vector with a magnitude K and parallel to Q. Hope people are understanding me here. If you're not understanding what I'm saying, rewind these words. The same words will run into your minds several times. For those who have recorded me, or for those who received me as a recorded teacher on a given storage device, make it a hard drive, make it a flash disk, make it a DVD. Immediately after a break, I'm coming with example 3. But example 3 of magnitude of the vector is going to focus on what we call a parallel vector, which part always disturbs students. But it is very, very easy. Don't go away, stay tuned. I'm very delighted to introduce to you example 3, a very, very good example. Yes, somebody can pause me right now and then first go and work out this example using your previous information and see whether you grasped. Or you can first watch this example, then you try out the trial numbers which are coming for you up to, after example 4, which is coming also. So find a vector which has magnitude 15 units and is parallel to 16I plus 12J. Very interesting. The only vector which is going to be parallel to a given vector is its unity vector. The only vector parallel to a given vector is its unity vector. If we have the x and y axes, x and then y, then plus j, the unity vector of y, j, and then the unity vector of x, I, we can include the z-axis, whereby its unit vector will be k. These are the vectors which are going to be parallel. They are the vectors parallel to those directions. J is parallel to y, and then x is parallel to I. I is parallel to x, or anything which will come after I here will be of a particular magnitude times I. We know very well that a parallel vector is represented in the form A is equal to KB, that A is now parallel, is going to be parallel to B. If at all A leaves B by a particular scalar, Okay, very interesting. Very interesting. Now, the only vector which is going to be parallel to this is its unity vector. We can go and look for the solution. Okay, now let us go and say the unity vector of of 16I plus 12J is given by the vector 16I plus 12j, this is j, then over the vector magnitude, the magnitude of 16 squared plus 12 squared. That is the vector which is parallel, which is a unit vector, and this is a vector which is parallel to this. So what we have got is a parallel vector to that. But what we are looking for, that parallel vector to this should be of magnitude 15. So we are going to multiply that row by 15. So let us first go and simplify this. We know very well that 16 squared plus 12 squared is giving us a particular value, which is 400. So square root of 400 is 20. Okay, square root of answer. Indeed, it is 20. So this is going to be the same as 16I plus 12j over 20. Very interesting. So the required vector is going to be, okay, the unity vector is unity vector times the magnitude 15 times magnitude of 15 units. Magnitude of 15 units. So this unity vector or the required vector, or we can just say that thus the required vector is equal to our unity vector, that is 16I plus 12j over 20. The whole of this multiplies through by 15 units, because the parallel vector is of magnitude 15 units. So when we simplify this, you will accept that we can reduce this through by 5. So 20 by 5, we shall get a 4. Okay? And here by 5, we shall get a 3. So you have a 4 here, you have a 3, which are remaining. Then we can go and cancel out by 4 once, by 4, 4. 4 times 3, we get a 12I. Good. By 4, there is a 4 here, by 4 once, by 4, 3. 3 times 3, that is a 9j. So the required vector, which is going to be parallel to 16I plus 12j, okay, with the magnitude 15, is this vector. If we remove the magnitude 15, then what we are going to remain with is a unity vector. And always a unity vector is the only parallel vector to a given vector. We can only increase its magnitude. We increase the magnitude of the unity vector to remain parallel, but again in a larger format. Hope people have understood me there. Let us go and look at the very last example on this concept of magnitude. Before now, we bring in other concepts. Okay, so immediately after a break, I'm coming with example 4. Don't go away, stay tuned. From the break, you are welcome to example 4. Yes, you are my learners, not my students. Students are there only to study. They may not learn, but hopefully you are learning tonight. So, example 4. If A is equal to 2, 7, 7, that is a column vector, meaning 2I, 7J, 7K. Okay, B is equal to 6, negative 3, 2, and C is 0, negative 4, negative 3. If a vector is presented in the column matrix form, then we need to show its scalar, its size. Even if the size is 0, we need to show it in that direction. If it was in form of the unity vectors, the I, J, K, we would just write negative J plus 3K. That would show that it has a 0 magnitude in this I direction. So somebody has given you the vectors A, B, C, then find a vector that is parallel to the resultant of A, B, and C. Resultant means addition. That's why I'm reading this as resultant. So find a vector that is parallel to A plus B plus C and has a magnitude of 50 units. Very interesting. First of all, our first challenge is finding A plus B plus C. Can we find that? Yes, it is possible, of course. So we shall come here and say, Mr. Examiner, sir, this is our solution. This is the solution. So in our solution, A plus B plus C is our resultant. A plus B plus C is our resultant. So this is going to be now equivalent to, we bring these the column matrix formats to 7, 7. That is A. Then plus, okay, a 6, negative 3, 2. Hope you are seeing what I'm writing on the board. This is a 2. This is a 2. Then plus vector C, and vector C is 0, neg 4, neg 3. 0, neg 4, neg 3. Okay. So this is now going to be, we can go and add the I components. 2 plus 6 plus 0, which gives you, oh, it gives you 8. Good. Then we add 7 to negative 3, and then to negative 4. You'll accept that you get a 0. Because 7 plus negative 3, that is a negative 4. I mean a positive 4. And a positive 4 plus a negative 4, you'll get a 0. Or 7 minus 7, which is a 0 in the J component. I mean the J direction. Y direction for the J component. So 7 plus 2, that is a 9. 9 minus 3, that is a 6. So we shall have a 6 here. So that is the resultant. Or we can come and say that R is equal to 8I plus 6K in that unity vector format. J has a 0 component. That's what it means. But if you're putting it in column form, you have to show us the 0. Very interesting. So we need to see the unity vector of this. Unity vector, because it is the only vector which is going to be parallel to our resultant. So unity vector of R, okay, is equal to, we say it, go and write vector R, then divide it through by its magnitude. So the magnitude of this is 8 squared, then plus 6 squared. So which is the same as saying 8I plus 6K, then over 10. So that is a vector which is parallel to 8I plus 6K, and it is the unity vector. So they are asking for a parallel vector to the resultant, and we have got a parallel vector to the resultant. However, the one which is required should be of magnitude 50 units. So we go and multiply our obtained parallel vector by 50. Are we together, dear viewers? Are we in the same blanket, the blanket of mathematics? Are you feeling the same warmth of mathematics like I'm feeling? Very interesting. So we come and say that the required vector, so thus required vector, okay, is 8I plus 6K over 10, and all of this we multiply through by 50. So this 0 will cancel out with that 0. So we are going to remain with 5 times 8, which is 40, and then 5 times 6, which is 30. So this is going to be the same as a 40, a 0, a 30 in that column form. That is the required vector. Or you can state it as 40I plus 30K. It is the required vector. Now in that kind of arrangement, that means that we have answered the question in the column matrix form as given by the examiner. That is the correct answer. Hope people have picked a leaf from these examples. It is now time for you to try out your questions. Yes, try out questions on your own. Trial numbers or an assignment is coming immediately after this break. Go away, stay tuned. Now your assignment. Since you're not familiar with my handwriting, some of you may not see it. I'm going to read for you through. What is indicated in red ink are the answers for those corresponding parts. Yes. So number 1, if A is equal to 3i plus 4j, B is equal to 4i plus 20j, and C is equal to 5i minus 19j, find part A, the resultant of A and B. Part B, the resultant of A and C. Part C, magnitude of A. Part D, magnitude of B. Part E, magnitude of A and C. Okay. And B, magnitude of A and B, that is E. Then part F, a vector that is parallel to A and has a magnitude of 15 units. And that answer is given here as 9i minus 15j. If you get it, then it means even what you have calculated here will also be something very correct. A vector that is parallel to A plus B and has a magnitude of 100 units. I've also given it to you here, 28i plus 96j. If you get it, it means what you have here will also be correct. These are very simple. I've not quoted for you the answers. Then number 2, if A is equal to I minus 3j plus 2k, then B is 5i minus 4j, and finally C is ci plus j plus 4k. Find part A, a vector that is parallel to A and has a magnitude of 28 units. I've quoted answer for you here. It is 2 root 14 brackets I minus 3j plus 2k. That is the answer for number 2, part A. Then part B, go and find a vector that is parallel to A plus B plus C and has a magnitude of 5 units. I've quoted for you the answer. The answer is 5 over 11 into 9i plus 2j plus 6a. That is all about the magnitude of a vector. Immediately after a break, we are introducing another concept other than the magnitude.